Hello everyone. How are you guys doing?
Hi. We're good. How are you?
I'm doing okay. Thank you for asking.
I'm so sorry about your YouTube channel. I hope you know it was like a really big help for us. So thank you. I'm so sorry that it got banned.
I know I'm trying to, I'm writing to them, like I'm doing an appeal, but it's not guaranteed that I'll get it back. But I really hope because I lost everything. Zoom doesn't have any of my videos because they have new system where they delete everything. So all of my videos and everything is gone. I have nothing. Like, man. So thank you so much, guys, for your kind emails. I received many emails. I didn't get time to respond because so many things are going on. So thank you. So my goal for today is to talk about final exam. With my morning class, I did few topics, 6 topics I think, and we have total 18 topics. So I still have 12 more topics to talk about, but I'm pretty sure I don't have time. So I'm going to go over as much as possible. So I'm going to keep talking and talking and talking. And anytime you don't understand anything, stop me. Okay? Unmute your microphone, stop me, and ask me a question. And I want to go over the topics which you have in your exam, second exam first, and then I'm going to cover the other topics. Okay? So start with series and sequence. So let's do the right page first. Nice one. So just find the sum. It means we're adding all these numbers. Unfortunately, it might be a big sequence, so we cannot possibly add all these numbers. So we need to know how many numbers we're actually adding and what type of sequence we are working with. If it's a geometric sequence, we have one formula. If it's arithmetic sequence, we have another formula to find the sum. So step one, figuring out what is our sequence. So if you look at the difference, 4 minus -2 is 6. -8 minus 4 is 4. So obviously don't have the same difference. Since they don't have same difference, so it's not arithmetic. So we want to see if it's geometric or not. So look at the ratio. So ratio we find by dividing the later number by the previous number. So 4 divided by -2 gives us -2. And if you take this, we have 16 divided by -8, which is -2. So it's a geometric series. They all have any two numbers, they have the ratio -2 between them. That means we can find a formula. Geometric series has, I forgot. Okay, they have a format. The first one and then ratio to the n-1 when n starts from 1. So with this formula, we know what would be, which term would be the last term. But do we need that? I forgot the sum of the geometric formula. Who remember the sum of the geometric formula? We did it in our last class. Something with 1 minus r on the denominator. Remind me, guys, please, the formula. On the bottom, we have 1 minus r, and then we have 1 minus r to the n, and we have first term. Yeah, I got it. Okay, so this is the formula for the sum. We have everything except for one thing. We know what is our first term. We know what is our ratio. The problem is, what is n? They didn't tell us n. So this is actually the nth term. So we need to know what is the n. How many terms we are adding here? That means we do need the formula. So an is the first term, -2. Our common ratio is -2 and -1. This -2 has a 1. So in other words, we have -2, 1 plus. So it's basically -2 to the n. Well, I did it using the formula, but you don't have to do it using the formula if you can already see the pattern. For example, here, the first one is -2 to the 1. The second one is -2 squared. The third one is -2 cubed. The fourth one is -2 to the fourth. So if you already see the pattern, you don't have to follow the formula. You can simply write it's -2 to the n by following what you see. And our n starts from 1. Now we want to know which term is the last term. So we set our formula -2 to the n equals to the last term, 32768. Now, one of the method, it's algebra, so you have two choices. You write -2 to the n and -2 to the, the thing is we don't know what is this number. So either you keep doing -2, the multiples of -2 power, and see which one gives you that, you'll get the answer. Or you ignore the negative sign, 32768, and you apply ln. If you apply ln, then the n comes down as a coefficient, and you get n times ln of 2 equals ln of 32768. I'm telling you to ignore the negative sign because ln or log, they cannot take any negative numbers. So if you try to input that in the calculator, ln of negative this, you'll get an invalid answer. I mean, invalid error message. So that's why ignore the negative sign, work with the positive sign. To solve for n, we need to divide both sides by ln of 2. So the nth term, we go to the calculator. Let me put the calculator here. 32768. 32768 ln. We divide that by 2 ln 15. So the last term is the 15th term. That means finally we can find the sum. The sum is the first one, 1 minus r to the m, whole thing divided by 1 minus r. We have now all the information. Our first term is -2. Our common r ratio is -2, and our n is 15. Whole thing divided by 1 minus -2. So 2 to the 15 is a big number. If you want, you can leave it alone, but you do know from here you're going to get -2 to the 15. Because negative with the even power gives us a negative back. Now you can at least combine this negative with that negative. It turns into a positive. So it's 1 plus 2 to the 15 divided by 1 plus 2, which is 3. So either you leave it here or use the calculator and find out exactly how much is the number. Okay? Question? No? You will see one of these in your exam today. Did you already have your exam? No, right? Okay, so yeah, you're going to see one of these. The next one, same concept. And here you're finding the formula for the sequence. So since this formula has 3 parts, one is the sine, one is the top, and one is the bottom. So what I do is I do 3 parts and combine them together. So I look at the sign first. We have plus, minus, just alternating. And since the first one is positive, so it's -1 to the n plus 1 or n minus 1. Plus 1 looks more nicer. And our n starts from 1. It means for the first term, we have -1 squared, which is positive. For the second one, we have -1 cubed, which is negative. So it makes sense. Now I look at the top. The top is 4, 9, 16, 25. And I can already see the pattern. The first one is 2 squared. The second one is 3 squared, then 4 squared, then 5 squared. So we definitely have something square. And now if I want our n to start from 1, that means the first number 2, the first base 2, should be n plus 1. So we have 1 plus 1, 2, 2 squared. Then when n is 2, 2 plus 1, 3 squared. Makes sense. So based on our denominator starts from 1 unit after 1, so it's n plus 1. Now I look at the denominator. We have here invisible 1, so it's 1, 3, 5, 7, and we know it's all odd numbers. So it's an arithmetic sequence. You have 2 choices. Either use the arithmetic formula to get the formula here, or you can simply make up a formula. So if for every odd number, we have a formula 2n plus 1. But if you don't want to use that, no problem. Let's use the arithmetic process. We have the common difference 3 minus 1, 2. So our formula is the first one plus the common difference n minus 1. So 1 plus 2 n minus 1. We distribute, we get 1 plus 2n minus 2, and we get the same thing, 2n minus 1. So the formula we get from here is 2n minus 1, n starts from 1. And let's see, does it make sense? When n is 1, we have 2 minus 1, 1. When n is 2, 2 times 2 is 4, 4 minus 1 is 3. So yep, it does make sense. So we have part 1, part 2, part 3. We combine all of them together and we get our formula. -1 to the n plus 1 times n plus 1 squared. They go on the top, and the denominator we have 2n minus 1. And you should always indicate your n starts from where, 1 or 0 or 2. Where does your n start from? So combining all of them, you got your formula. Who wrote what? Can you do 33 from the review sheet if possible? I don't have the review sheet, but I can see if I can do it. 33 from the PDF review sheet. Okay, so give me 1 second. Let me go to the review sheet and see. Is it from exam 4 review sheet? Okay. 33. Or rewrite the sum as a single sum. Okay, let me write down on the paper. We have 10 plus sum 1 to 5, k square minus 1, sum from 6 to 10, k square minus 1, and then 3 sum 1 to 10, k plus 1. Okay. We have 10 plus sum k starts from 1 to 5 of k square minus 1, k starts from 6 to 10 of k square minus 1 plus 3 k starts from 1 to 10 k plus 1. Okay, the first thing I notice is this. In here, we have the same sequence, and in the first sum, we are adding all the numbers from 1 to 5. And for the same sequence, in the next term, we are adding all the numbers from 6 to 10. In other words, we can combine all of this into one sum. K starts from 1 to 10. Because first we're adding 1 to 5, then we're adding 6 to 10, and we don't have any gap between 5 and 6. It's only 1 unit. It's common to have 1 unit difference. So we combine these two. We start from 1 and we are adding total 10 numbers, 10 digits. And we have the sequence case. K plus 1. So we are we are putting 3 inside our sum. We are allowed to do so. So from here we get 3k plus 3. So we can, since we have the same sum, same many numbers we are adding, so we can combine these two. We are adding first 10 terms of the sequence k square minus 1 plus 3k plus 3. Since we are adding first 10 numbers, so we can say, well, we are adding two sequence and we are adding their first 10 terms. So you'll have to combine them. So when you combine them, we get k square minus 1 plus 3k plus 3. So 3 minus 1 is 2. We get k square plus 3k plus 2. And our sum starts from 1 to 10. Now the only thing left is 10. How can we rewrite this 10? Well, 10 is 10 is same as we are adding 1 10 times, right? If you add 1 10 times, we write 1 to 10. Even though you don't have 10, so even though you don't have k, but it means we are adding the same term 10 times. So we can rewrite this using a sum notation. So what do we have? The 10 becomes sum k starts from 1 to 10 of the number 1. The middle and the last one gives us k starts from 1 to 10 of k squared plus 3k plus 2. And now, see, we are adding same 10 terms for 2 sequences. So we are allowed to combine these 2 sequences. Why wasting our time writing the sum twice when basically we are doing the exact same thing? So we write the sum once, 1 to 10, and we add 1 plus k squared plus 3k plus 2. And we have like terms. So it means all these 1, 2, 3, 4 sum they gave us, they actually boil down to the simple formula k squared plus 3k plus 3. And this is what they're asking you. Combine all the sum into one single sum. So we combine 4 sequences, sequence 1, sequence 2, sequence 3, sequence 4. We combine 4 sequences together by combining their sum notation only once. Clear? And good question, because you're going to see this today in your classroom. Okay? Let me go back to my review. Okay, another thing you're going to see today are these two. Write down the equation for the ellipse and expand binomial. So for ellipse is this. We complete the circle twice. Ellipse has a format x minus h squared over a squared plus y minus k squared over b squared. The only difference between ellipse and circle is that circle has many radius. So our right side could be anything, but ellipse cannot have anything on the right side. It has to have one. So we have to do everything we need to do to have one on the right side. So let's complete the square. Oh, before completing the square, we need to combine x's and y's together. So 4x squared plus 40x, 36y squared minus 216y, and I forgot. Subtract 280. Yeah. So when we complete the square, before complete the square, we need to have our x squared term alone. That means we need to take out 4 as a common factor from the x's, and we need to take out 36 as a common factor from the y's. So 4x squared plus 10x equal 36, y squared minus 6 times 6 is 36, 6 times 18, 19, 20, 21, 6 times. negative 280, right? 6 times 6 is 36, 18, and then 3. Yeah. Now, to complete the square, we have 4x plus something square, 36, y minus something square, negative 20 plus 4 times whatever we are going to add here, plus 36 times what we are going to add there. So what goes inside is half of that amount, which is 5. And we add that square on the other side. Now what to add for y is half of 6, which is 3. So I need to add 3 square on the other side. Okay. And it's 4 times because this term has a coefficient 4 and 3 squared has the 36 times because we have a 36 on the outside. So whatever we took out as a common factor, we need to multiply by that, by the half of whatever we have in front of the variable. So if you combine all of these, I believe it will be 4 times 36. One 144. You can check. I believe it will be 144. So if you do 144, then remember, ellipse has to have 1 on the right side. So we need to divide every term by 144. And actually, I want to check. I don't want to give you wrong information. We have 5 squared, 25. 25 times 4 is 100. So 100 plus 3 squared is 9. So 9 times 36. Whatever we have, we subtract 280 from there. Yay, that's correct. So 144. So they cancel out. And 4 goes to 144 36 times. 36 goes to 144 4 times. In other words, we have x plus 5 square over 36 plus y minus 3 square over 4 equals 1. Now they will ask for h and k. H and k. So h and k means it's the opposite of whatever we have here. So your h is opposite of 5, which is negative 5, and your k is opposite of negative 3, which will give you 3. So hk and the formula. You need to do all 3. Clear? Okay, let me know when you have a question, okay? Otherwise, I'll keep going on because we don't have much time. Okay, the next one, binomial. So it's up to you which method you want to use. But if you do know the coefficient formula, then it will be easier for you. For example, to find the coefficient of the binomial, we do n choose r. It means NCR. So let's say in the exam, they're asking you for, let's say, x minus 5y to the 100 power. What is, let's say, 20 coefficient of this thingy, this binomial? So to find that, you use the formula. We have 100 total. We are looking for 20 factor. So you're choosing 20, we're choosing 100, choose 20. Using calculator, you can find that. And then with that, you need to multiply by that, if I'm not wrong. So it's -5. I forgot actually. 20. So, oh yeah, you need to multiply the coefficient for this one. So it's 1 to the 20 and -5 to the 100 minus 20. Oh yeah, I remember now. So 20 coefficient of this formula is 100 choose 20 times the first coefficient to the 20 times the second coefficient to the 100 minus 20. So if I remember correctly, the formula is n choose r, first coefficient to the r times second coefficient to the n minus r. I may be wrong, okay? I didn't do it for a long time, but as far as I remember, that's the formula to find the coefficient for any binomials. However, this question is different. It's specifically asking to expand this. So in your exam, you're going to two of these. One is expanding and one is find the coefficient for some term. So I need to know both. So I showed you one. Now let me show you another one. How do we expand x minus 5y to the 5? Since this 5 is a small number, so I would like to use Pascal's triangle because it's much easier than working with this coefficient formula. So Pascal's triangle says for the highest degree 2, our coefficients are 1 to 1. For the degree 3, actually I should use this. For degree 3, you start with 1 and then you add these two. 1 to give us 3, then you add these two, you get 3, and you end with 1. So you always start with 1, end with 1. And then the middle, you just keep adding to get the next term. So for the fourth degree, we start with 1, end with 1. And the middle is 1 plus 3, 4, 3 plus 3, 6, 3 plus 1, 4. So these are the coefficients for the fourth binomial. Now we are looking for the fifth binomial. It means one more. So we start with 1, we end with 1. And then we have 1 plus 4, 5, 10, 10, 5. So these are the coefficients what we're supposed to get using this formula. So instead of using this formula, I simply use the Pascal's triangle. That means our life becomes easier. So when we expand, we write 1 plus 5 plus 10 plus 10 plus 5 plus 1. These are the coefficients. And now we are going to do the first x to the 5 power negative 5y to the 5 minus 1 fourth power. Right? If you have time, can you repeat it for the revision? Okay. Remind me later, okay? No, not 4. Sorry. It's 1. Like 0. Because when you add them, it has to be total this much. So if you have n, yeah. So the second one will have x to the 4 and negative 5y to the 1. When you add them, you'll get 5. Yep, makes sense. Then we have x to the 3, x to the 2, x to the n, and then we have x to the 0. So we have negative 5y to the 2, negative 5y to the 3, negative 5y to the 4, negative 5y to the 5. So if you observe, all the x powers are going down one by one. And our first term is x. Now our second term is negative 5y. So negative 5y, the first is 0, then negative 5 by 1, negative 5 by 2, negative 5 by 3, negative 5 by 4, and finally negative 5 by 2 to the 5. So you always start from 0, goes up to n. And now when you combine all of the information, we get, this is 1. So first term is x to the 5. Now if you multiply these two, we get negative 25. So negative 25 x to the 4 y. In here we have negative 5 squared, which is 25. 25 times 10 gives us 250 x cubed y squared. In the next one, y should be minus. We have negative 5 cubed. Now negative 5 cubed is negative 125. So negative 125 times 10, negative 1250 x squared y cubed. Now in the next one, we have negative 5 to the 4th, which is 625. 625 times 5, I have no idea. So 5 times 625, x, y to the 4. And now x to the 0 means it's cancel out 1. And you're left with negative 5 to the 5. Whatever that is, y to the 5. Okay. So I didn't explain this to you because I don't know. But you allowed to use calculator. You're gonna find them. And at the end, all of this is the expansion of plus of this thing, the fifth binomial. Question? No? Okay, anything else? Maybe not. I don't have anything else which you'll have in your exam too. In my slide. Now, let me go over trigonometry because it's harder than the other stuff. So, one of them will be find the solution, like this. What you notice here, first thing is that they both have the same coefficient. So you can divide both sides by the coefficient, they cancel out. Second thing you notice is that it's a double angle. So anytime you see double angle, you need to apply double angle formula. Cosine has 3 formulas for double angle. My favorite one is cosine squared x minus sine square x. So expand your double angle. On the other side, we have only sine x left. Now here you see we have two functions. One is sine, one is cosine. It's hard to work with. So since we have two sines, we are going to keep the sine and you're going to rewrite cosine square in terms of sine. We know sine square plus cosine square gives us 1. That means cosine square is 1 minus sine square. So cosine is same as 1 minus sine square. We are going to apply that here. Cosine square is 1 minus sine square x. And we have this, another sine square x. And let's subtract this negative sine x equals 0. We want to bring everything to one side so that our goal is to factor them. Now we have like terms. So negative sine square x minus sine x plus 1 equals 0. Well, we don't want our sine square to be negative. We want to start with positivity. So we're going to multiply or divide both sides by negative. We get positive sine square, positive sine, negative 1, 0. Did I do something wrong? Yeah, I did something wrong. Sine square minus sine square gives us 2 of them. I missed that. We have negative 2 sine square. Okay, so why need factor? If you don't want to use factor, you can have your own method. But recently I learned about a shortcut version of the AC method. If you do want to use AC method, you choose AC method. But the shortcut version says it's called AC method, okay? But it's called shortcut. Now AC means you need to multiply A with the C. So in shortcut AC version, what you do is you don't write A. Instead, you write sine square plus sine. And instead of C, you write A times C. So A times C is 2. AC is 2 times 1. That gives us 2. That comes here. And now factor, just like normal factoring. We know two numbers multiplied to 2 combined to 1 gives us 2 and 1. So we have sine x plus 2 and sine x minus 1. So two numbers multiplied to negative 2 combined to positive 1. Multiplied to negative 2 combined to positive 1. It's negative 2 times positive 1. Sorry, positive 2 times negative 1. So we have sine x plus 2, 0, sine x minus 1, 0. That gives us sine x is negative 2 and sine x is positive 1. And now we do something weird. See, this is the solution for the shortcut of AC method. But we didn't have this originally. So since we got this originally we had 2. Where did the 2 go? We didn't do anything, right? So once we solve for x, we need to get these 2 back in our solution. So we divide the solution by 2, what we ignored previously. That means we got sine of x is -1 and sine of x is 1/2. Now they're asking to find all the solutions from 0 to 360. So if you look at the unit circle, here we have sign positive. So we have two solutions for positive sign. And here our sign is negative. Sign is -1 is somewhere here. Sign is y. So we have -1. Y is -1 is here. We have another solution here. So we have one solution in the first quadrant, one solution in the third quadrant, and another solution is this one. Our y is -1 here. So this one is easy. -1 is 270 degrees. So our x is 270 degrees. And in here, they're asking sine of which degree is 1/2. So if this is your x, your opposite is 1, your hypotenuse is 2. Now, if you memorize your unit circle, your life is easy. If you don't, then think about the special triangle. In the special triangle, which triangle has opposite side is 1? 30 degrees. So that tells us one of the solution is 30 degrees. But we have two solutions because sine is positive twice. So if this is 30 degrees, we have another 30 degrees here. But when we find a solution, our angle has to start from 0 degree. So if this tiny angle is 30 degree, that means the angle that starts from the origin, from the 0 degree, is here. So the big one is 180 minus 30 degree. That gives us 150 degree. And that's how we have three solutions. Two are positive from first and second quadrant. And another one is y is -1. Y is -1 at 270 degree. So we have total three solutions. Any question? No? Okay, now my favorite type. Here, like I said before, anytime you have inverse, your life is easy because inverse means draw a triangle. So we have two inverse inside. That means we are going to draw two triangles. And let's say sine gives us angle A and cosine gives us angle B. So this is angle A and this is angle B. Now sine is opposite of our hypotenuse. Cosine is adjacent of our hypotenuse. That means from this angle, our opposite is 12, hypotenuse is 13. From this angle, our adjacent is 7 and our hypotenuse is 9. That means you have to find the missing side. So this missing side is 13 square minus 12 square under the square root, whatever that is. And this missing side is 9 square minus 7 square under the square root. We got them from a square plus b square equals c square. C is the hypotenuse. So whatever that is, okay, I don't have time to calculate that. Now at the end, we have this sine angle A plus angle B. So whatever we get from the inside, that's the angle, and we just put the angle. So now we have to use the sum formula for angle. If I remember correctly, sine is general, so it takes one, give another one to the cosine. So sine A, cosine B, plus sine B cosine A. So you go to the A function, A triangle, and we find what is sine of that A. Sine is opposite of our hypotenuse, so we get 12/13. In the B, cosine is adjacent of our hypotenuse, so 7/9. Now in B, sine is opposite of our hypotenuse, so opposite is 9 square minus 7 square under the root, and our hypotenuse is 9. In the A function, cosine is square root of 13 square minus 12 square over the hypotenuse. Whatever you have for the simplifying, that's the answer. So multiply these two, and that's it. Question? No. Then we have other way around. What if we don't have the inverse inside? Inside we have original one. So if inside is the original one, then you are gonna find its length. For example, pi over 6 is 30 degree. Why I can't write here? Can I write here? Yeah. Okay, right here. So let's do this question. We have sine inverse of the cosine negative. You remember from before that cosine is an even function. It means the negative doesn't affect the cosine. So cosine of negative function is same as cosine of the positive function. Okay. So this is same as sine of cosine positive 5/4. Now 5/4 is 45 degree. So 45 degree, we have 1/1√2. So basically they're asking which angle of sine gives us cosine is 1/2. Which angle of the sine gives us 1/2? Well, from here we have opposite 1, √2 is hypotenuse. So this is same as 45 degree. So it's pi/4. So from the inner, we get a length, and based on the length, we get an angle for the inverse. Okay. Any question? Comments? Do you guys want to keep going on, or you want to stop? I can do one more. Okay. For example, simplify or verify identities. So anytime you see any other quadratic, any other trig besides sine and cosine, always convert them into sine and cosine. That will help you to go somewhere. So cosine is 1/sine. So enough cosine. Cosecant is 1/sine. And cosine, we keep it because cosine is fine. But cotangent is cosine over sine. Okay. Now we see on the denominator, we have cosine, both terms. We can actually pull out cosine from the denominator, cosine x. If you pull out, we get 1 plus 1/sine x. Look at the numerator. It's the same thing, 1 plus 1/sine x. So this and this They are the exact same thing. So we cancel them because one is at the top, one is at the bottom. We get one on the top, cosine x on the bottom. That gives us secant x. And we are fine. We are done. That's all we have to do. Okay, no problem. So, yeah, good luck with everything, guys. Good luck with the final exam. And today's exam. Okay.